Hello, everyone. I'm Ashwin, currently a research assistant at Simon Fraser University. And as part of this year's ESoWC, I'm working on CliMetLab project along with my mentors, Bodwan and Florian. So CliMetLab is a Python package with 4 main functionalities. It provides easier data access to the climate and meteorological datasets. It works on the processing of these datasets like format handling, the data loading, the data rollers that we have to write. It also works for the interoperability of these datasets. So say you want to have these datasets to be loaded with Jupyter notebooks, then you have SciPy stack to handle datasets such as NumPy, Pandas, and all. And also the machine learning frameworks such as TensorFlow, Keras, and PyTorch. And after this, you have the output from this data science or machine learning project pipeline that you get something such as a trained model, and you need to do inference over that. So you get to have some form of graphs and curves such as training curve, the loss curve, and many more. So CliMetLab aims to act as a one full package which can provide all these functionalities. It also has this plugin architecture, so that provides easy addition of data sources, data sets, and plotting styles. As part of this project, like for this 4 months, I'm keeping the scope to these 3 things, mainly adding a Matplotlib driver, adding index source plugin, and working on Zarr format for large-scale data storage. This is an experimental part since it involves many experiments to try out with different size of data sets and different compression formats and all. So I'll be presenting that as well. So again, so the main project goals involve these 3 things that I just mentioned. So to extend CliMetLab so that it seamlessly interfaces with Intech and allows users to access all Intech compatible datasets. This involves CSV files, NetCDF files, GRIB files, which are mainly relevant to the climate science community. Then second would be the extend CliMetLab so that it offers user with high-level Matplotlib-based plotting functions. This is really important when we are going with machine learning, like the projects in machine learning community are mainly based with Matplotlib as the plotting library. So currently, CliMetLab is based with Magix, which is a go-to package for many of the ECMWF software set. But we want to add Matplotlib so that we can have this plume plots, ROC curves, the training curves as an additional function. And then we want to try to compare the data format Zarr with the NetCDF and GRIB format and to see how it performs with small scale as well as large scale data sets. So as I mentioned, these 3 tasks are divided in. So for the first task, this task is completed for now as part of from when I started working till now, this part is completed. So this is what I'm doing here is mainly Intech provides. So previously, CliMetLab had the data sets to be added as just you had to write your own data format, how exactly you are going to get that. So say the data extension, if it's a CSV, it's an NetCDF, and this had to be done. So but with Intech, you can just import CliMetLab CML, and then you just load data. It calls the Intech package that is currently being added as a plugin. It's added as a source plugin, and then it infers what kind of data that you are trying. So you don't have to handle that functionality anymore. So it does that for you. This package is released on PyPy and it can be installed via pip. So it's ready to use. And it provides currently the support for CSV, NetCDF, Zarr, GRIB, and Pickle files. So this is mainly we are going in the direction of machine learning projects. So moving ahead for the second task, which is mainly around the Matplotlib thing. So Magix is currently the go-to package as part of ECMWF suite of softwares for plotting. But the machine learning specific graphs can be handled better with Matplotlib. And since Magix is a package for is being there for a long time, it's there for mainly to handle the climate the data sets functionality, but not specific to machine learning things. And that's why we are trying to add Matplotlib here. So in the short term, Matplotlib integration into CliMetLab for plotting functionality from ML point of view with use in Jupyter notebooks. And in the long term, with further development and adding more functionalities, it can be as good as Magix so that we can get all the functionalities which are currently present in Magix with Matplotlib. So this will require more and more development, but currently we are focusing on few important things which are relevant to the machine learning projects. So yes, so currently the setup in CliMetLab is you get the plotting functionality with a driver, which is currently Magix. It calls the action package, and then it calls the plot figure module. what I'll be doing here, and currently I'm working on this. This is a work in progress. So what I'm just adding, like I'm providing the user to have two drivers as the options. So one would be Magix, another would be Matplotlib. And these actions would be selected based on what the curve you select. So say you want to plot the training error curve. So the driver would be called would be Matplotlib, since Magix doesn't have that functionality yet. And then it can be done with that way. So next, I'm just showing it. Here is a figure which was previously done by Magix, but now it's being plotted with Matplotlib. This is for the sea level pressure field. Then another figure, which is this for the precipitation field, which was previously done with Magix, and currently we are able to do that with Matplotlib. Okay, so moving to task 3. Okay, mainly we get data sets like the climate and weather related data sets are of different sizes. So for small scale data sets, the conversion between different data formats is really trivial, and there are many APIs available for that. So here I've added 2 examples. So first, if you look at, say, an NetCDF format to be converted into Zarr format, what you do is you just load Xarray as XR, and you open the data set, and then you just convert it to Zarr. Also, for GRIB format to be converted into Zarr format, you just load the data set with Xarray, and then you just convert it to Zarr. This is really easy and possible for small scale data sets. But when we are moving to data sets of huge sizes, then it's not really that feasible. And that's why we need to move to we need proper methods to how we are going to convert this data set into Zarr format. The main concerns with data storage are can be summarized as these 4 points. So we need multi-threaded parallel read and write when we are handling data. We also want to avoid swapping via chunking strategies. So what we mean by chunking is that we should be able to store the data in the form of chunks so that it can be easier to access, and instead of having the swapping thing. Then many of the times when the data sets are stored on, say, on server or mainly like cloud-based storages, compression and decompression happens so that data sets can be stored efficiently. But this compression and CPU time is required to this compression and uncompression. We need to reduce that. And again, the local performance is okay. We can do that. Once we download a data set, we can have it locally and just load it and all, but it's not feasible all the time. So most of the data sets are stored on cloud storage. So we also need good functionality to handle those as well. And that's why we have to have a format which can work well with considering all these possibilities. And that's why we have different, currently I have tried to compare what we have with NetCDF GRIB and what we can get with Zarr. So NetCDF and GRIB are most widely used formats, for the archives of climate science datasets. The storage formats for these files are based on NetCDF binary format and HDF5 format. And this provided effective disk storage in the past, but it does not work really well with cloud storage. This claim is done from the recent work that is done by the Pangeo community. Pangeo community handles this climate-related data set, and they have their own framework for that. And they have performed this study on how we can move from, they're also trying to move from NetCDF to Zarr. So this is the claim from their study. And also, in order to read a single variable or metadata, whole file read is required. So this is a really inefficient thing, and we don't want to do that. This happens mainly due to the opaque nature of these files. Also, the NetCDF and GRIB formats are ill-equipped at handling the concurrent data access. So there are many issues currently faced with NetCDF and GRIB. So that's why the Zarr format is a really good one, and it can be a good replacement for NetCDF and GRIB. Zarr provides us with parallelism, so it has this multi-thread and multi-processing thing. It helps for the data storage in chunks, so you don't have to have the swapping thing, but you can just go for the chunks of the data, and so you can access them at once instead of going step by step. Then the metadata with Zarr format is stored in one place, so it gives us a single read operation instead of the multiple read operations that we had to do for each variable. We had to do multiple single operation in NetCDF format. Zarr arrays are mainly stored as key values, like key value thing on object storage systems, and as a hierarchical directory store on POSIX file systems. This provides a really good way to access the data. So for the POSIX file systems, we mainly have this hierarchical directory, and that can be a good replacement for what we have with NetCDF and GRIB. Also, the chunk functionality provides reliable use in case of the data transfer. So when we are, as is mentioned in the next thing, so say we are trying to get data from a server or from cloud-based storage and the connection drops. So you can just pick up the last chunk of the data already written and continue the retrieval process with just one append option. This is one of the good functionalities that is really important, since there can be network issues that arise when we are trying to get data, access data. And that's why these are some of the functionalities from Zarr, which I studied like while creating the proposal of this project. But that's the point of that would be the next thing. We'll try to explore many more things possible with Zarr and see how it can be done, like how it can replace the NetCDF and GRIB formats. Okay, so the major subtask for this task would be to compare Zarr, NetCDF, and GRIB. Then test the sequential as well as asynchronous operations on large data sets. Like we'll be deciding different size data sets, and then we'll compare how Zarr performs like for the access, for the read write, and all these things when compared to GRIB. We also want to try with different chunk sizes for the multiple data sets. So there would be chunk, we want to see if it scales well with if we go for larger chunks, or it scales well only if the chunks are small. So that is something to be seen. Then the data compression is a factor that, as I mentioned, data compression plays a major role in data access, and it provides a set of data compressors. So you can select which form of compression you want. And so what we'll try to do here is to use these different compression techniques and benchmark the performance as can be shown with and like useful for the results based on the data. Also, there is another format named N5, which is similar to what we have in Zarr, and it handles the data in similar way. And there is a combined format which is given. So we'll be seeing if we can go with Zarr and N5 as well. And that would be the next step. Like once we are done with this comparison, we can also try to see if N5 is a good thing to do. So this is part to be done, and this is mainly an exploratory work. So this would be how some form of kind of a little research thing to do, like as I mentioned, different chunks, different compressors, and all these things, so that we can actually benchmark on how good Zarr is if we are really want to move from NetCDF and GRIB to Zarr. So that's part of the thing. And yes, so that's it for now. And I'll be happy to take any questions if you have. Thank you.